Question 28 is our last star question. It's a tough question because there's no numbers in here, but hopefully you'll understand about what I'm about to say. So, first of all, you need to understand what the word congruent means. Technically means exactly the same size. It's not just a similar triangle, which could be an enlarged version of it. It means exactly the same size. So we're trying to say that this triangle here is exactly the same as that one, just in a slightly different position. Now, you should be able to see here we have a chord, and from that chord it goes up to the circumference and to the other end, and up and down. And we know that these two angles are the same because of the angles made from a chord. So I've said here below, I'll show you in a minute, ABD is the same as angle ACD because they're the angles from the same chord. Okay? So to prove that they're congruent, I need to say that they have the same angles and same sides, basically. Now, we're also told that these are diameters. So if this is a diameter, and then you go to the circumference, you always make a 90-degree angle there, which means from this diameter, this is also 90 degrees there. So angle BAD is the same as angle CDA, and they're both equal to 90. Angles from a diameter is 90 degrees, always. And because I've just proven that that angle exists in both and that one, it means that this angle here and this angle here are also exactly the same. So I've put, therefore, these two remaining angles, these two remaining angles are the same because angles in a triangle are up to 180. Now, that's not enough, because imagine this. Imagine that is 60, 60, 60. Equal, let's put the lines on just to prove that. So is this one. Just because the angles are the same, it doesn't mean it's congruent. It means it's similar. So we've actually got to link the sides to it as well. Now, I've said this first, because that is a diameter and that is a diameter of the same circle, that they share a length. So I've said here that AC equals BD, they're both diameters. I should write both diameters of the same circle. Both of them have this side here, AD in them, that one and that one, both have AD. So I've had both have AD as a side. And what I should have maybe, or could have, maybe a bit overkill, and maybe I didn't even have to do all that stuff about the angles. I could say, using Pythagoras' theorem, that this side and this side must be the same because they have the same here and here. So I didn't actually have to do anything on the angles, because if you prove the sides are the same, then it has to be exactly the same. So it's a bit overkill, but there's nothing wrong with that. So actually therefore both have three sides and three angles the same. 3 marks.